see here consists of the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Items like comets, asteroids, and some dwarf planets, which we won't mention a lot about. So our solar system does consist of the Sun, its planets, and everything else that goes around them. It's totally dependent on the Sun. It's what holds everything together due to its gravity. It's what provides energy. It's the most important part of our solar system. Any planet that you can see, and some nights you can see other planets, especially Venus, you're only seeing light that's reflecting off of it. The Sun is the only object that creates its own light. So if you look here, we have group 1 planets. They're called the inner planets here in the blue box, and the outer planets here in the green. You should notice a few obvious differences, one being the size. These planets are much, much bigger, and you can't see it, but these also all have rings. Saturn the biggest, Uranus the second, but they all do have at least faint rings. So how do planets form? Basically, we talked in our last set of notes that when a star, like our Sun in our solar system, is born, it creates an explosion. And that explosion shoots out rocky material and gases. Since gases are lighter, they get shot out further from the Sun when it's first formed, and the heavier stuff, like the rocks, get shot out closer. Once that happens, gravity takes over. So the gases that got shot out the furthest and were closest to each other slowly started to pull together due to gravity. And that's how the outer planets formed. They're all made of gas. They're called gas giants. And the reason they're made of gas is gas got shot further. The inner planets are all made of rocks. They're terrestrial planets. And rock obviously weighs more than gas, so it didn't get shot out as much. Eventually, the rocks got pulled together due to gravity through a process called accretion, and we had our planets formed. This short video, you're going to take, I think, a little bit of notes on it, or does it have questions? Sorry, give me a second. Yeah, you're going to write down at least 3 important facts from this video. So anything you find interesting or important, write it down and make sure you get it within the first 3 minutes or so, because that's all this video is.
Orbiting around our Sun, we find asteroids, comets, and planets with their moons. But how did our solar system form? Around 4.5 billion years ago, a cloud of mostly hydrogen gas and dust started to collapse onto itself. It spun faster and faster, flattening out to form a disk with a dense center. This center got so hot, it started making light, and our Sun was born. Around our baby Sun, there was still a spinning disk of gas and dust. Over time, it cooled and came together due to magnetism and gravity. Close to the Sun, metals and rocks began to form, but it was still too hot for other materials to become solid. They remained as gases. Further from the Sun, where it was cooler, water and other ices could form. They came together to make larger pieces, called planetesimals, which then joined to make large planets. These planets had enough gravity to capture the surrounding gas and became the gas giants, Jupiter and Saturn. Some scientists think Jupiter formed first and was pulled in towards the Sun by the swirling material in the inner disk. When Saturn formed, it moved inwards too. The planets got closer and swept up the gas between them. They then began to journey outwards together. Jupiter's large size stopped rocky material clumping together. The asteroid belt is full of these rocky scraps of the solar system. It might also explain why Mars is smaller than expected. When Jupiter moved inwards, it fed on lots of material, so later Mars had less to form from. In the inner solar system, chunks of metal and rock slowly came together to create the rocky planets. Within 100 million years, early planets were orbiting the Sun with lots of leftover material in between. The young Sun had a phase of releasing strong winds. It blew the extra gas outwards, stopping the rocky planets and early gas giants from growing. spin around the snowball cores of the ice giants Uranus and Neptune in the outer solar system. Many of the leftover ice balls flew out into the spherical Oort cloud. They occasionally got flung inwards, becoming comets, and collided with the rocky planets. Perhaps comets brought ices and gases back to these planets, providing material for their atmospheres, and also bringing water to the Earth. For the first billion years, many stray pieces of rock and ice would have been flying around, creating lots of collisions. The Earth's moon could be the result of a large object impacting the Earth. Similar impacts may have reversed Venus's spin and knocked Uranus onto its side. Some of the planetesimals still floating around were captured by the giant planets to form moons around them. Scientists are looking to distant stars with exoplanets to see how they feel. Maybe then we'll know if we truly live on a unique planet in a very special solar system. Orbiting around our...
All right, hopefully you got your 3 notes from that. If not, you can rewind and get them. So we're going to start with the sun, since we said it's the most important part of our solar system. It's the heaviest, the biggest, and it's just a ball of hot burning gases, hydrogen and helium. It's by far the closest star to Earth, and we said light travels at 186,000 miles per second. Even with that speed, it takes the sun, the light that leaves the sun, 8 minutes roughly to reach Earth. So when you look outside and see the sunlight, that sunlight actually left the sun 8 minutes ago. On Earth, we should know this from our other sciences, that it's the source of all energy for life on Earth. We need it to keep the Earth hot enough. We need it for photosynthesis, and that's the basis of food chains with plants. Most of the sun is hydrogen. The rest is helium, because we said hydrogen fuses into helium when nuclear fusion happens on stars, so that should make sense. And since our sun is relatively young, about 4 or 5 billion years old, it's still mostly hydrogen. You will notice, if you've seen pictures of the sun, that there are dark patches on the sun's surface. Those are sunspots, and really what they are is patches of gas that are slightly cooler than their surroundings, which makes them a little bit darker. Then we have our planets, and planets are just objects out there in space that orbit a star, in our case the sun, and they go in elliptical orbits. Remember, elliptical is a shape of galaxies, and it's just kind of egg-shaped, so it's not perfect circles. And we used to think there were 9 planets, but we got rid of Pluto as we learned more and called it a dwarf planet. There's a few reasons why. All planets orbit in the same kind of plane, except Pluto did not, because they don't think Pluto actually formed when the other 8 planets formed. And as they were able to discover more things, they found a number of planets past Pluto that look like Pluto, different orbits and everything, and they realized either those are also planets or Pluto actually was not a planet, and they decided to classify all those objects as dwarf planets. So our inner planets, which we said are rocky terrestrial planets, in order as closest to the sun, are Mercury, Venus, Mars, and Earth. Then we have an asteroid belt separating those from the outer planets, which are Jupiter, Saturn, Uranus, and Neptune. And actually, for some reason, Earth is before Mars. All right, no big deal. So now we're going to talk about some traits of each of those planets. I mentioned this. There's an asteroid belt, and it orbits. It stays in this area all the time between Mars and Jupiter, separating the inner and outer planets. And go ahead and put all this in your notes. Remember, these 3 things are notes you got from the video, so if you missed them or didn't get enough, go back and watch that YouTube video again. All right, so the closest planet to the sun is Mercury. It's named for the messenger of the Roman gods because he had winged feet, so he was very fast. Well, Mercury travels around the sun the fastest, meaning it has the quickest year. It has no atmosphere. So on Earth, I mean, whether the sun's out or it's nighttime and it's not, the temperatures don't change that much. We're talking, 10 to 20 degrees most days. Without an atmosphere, Mercury is ridiculously different between day and nighttime. In Daytime, when the sun is hitting close Mercury, it's 400 degrees. At nighttime, it's negative 180 degrees. So the lack of atmosphere really affects the temperature on Mercury. It does not have any moons, has no atmosphere or water, we said. You can see it with your naked eye on a clear day if you know what you're looking for or where to look in the sky. And a year on Mercury is only 88 days. It takes 88 Earth days to go around the sun, to revolve around the sun one time. Moving out, Venus is the next planet you're going to call, and they call it the veiled planet because it's surrounded by such thick clouds. So they say it's like a veil covering it. It is by far the brightest and hottest planet in our solar system, and it orbits the sun in about 225 Earth days, so a shorter year than Earth. It's also sometimes called the morning star or evening star because it's the brightest in our sky right before sunrise or shortly after sunset. You've probably seen this in the sky whether you realize it or not. It's the closest to Earth in terms of, well, both distance, but also size. So they call it kind of a sister or twin planet to Earth. Let's go put this in your notes. Press pause here. Then we get to Earth. We should know a lot about Earth. It's about 70% covered by water. Reflects about a third of the sunlight it seems. And the Earth's atmosphere scatters that light, and that's what creates its blue effect. And we obviously know we're the only planet that has life on it, at least in our solar system. Hopefully you know the orbit of the Earth is 365 days to revolve around the sun one time. It also rotates on its axis, which makes day and night, and that takes 24 hours. We know what a day is, 24 hours. And because the sun or the Earth is tilted on its axis, actually, let me get out of here, change it so I can color on it a little bit. Let me get out of this. Sorry. You can see this shows the tilt of the axis. It's not straight. It's not up and down. If it were perfectly up and down, the axis would cut through like that instead of like this. So, notice, in this part of the year, the northern part is closer to the sun. So the northern hemisphere where we live is summer. Here in spring, the north and south are receiving about the same because the way the Earth is tilted. So it's not that the north or south is closer, like over here. In winter, you can see the south is closer to the sun, so the south would be the southern hemisphere, would be summer, but we up here, since we're further away, would be in winter. Spring and autumn, both north and south are even because it's kind of on its side, and temperatures are similar in spring and fall, so that's why. The moon is the Earth's only satellite. Satellite is something that orbits something, so the moon orbits the Earth, so it's considered our satellite. It looks big, but it's really about a fourth of the size of Earth. It just looks really big because it's close to us. The moon doesn't have an atmosphere, so just like Mercury, there's a big difference between day and nighttime temperature. Daytime temperature on the moon is about 127 degrees, nighttime negative 173. It can't trap that heat. Because there's no atmosphere, there's no weather. It does not rain, there's no wind, there's no clouds on the moon. And you've probably seen pictures of people walking on the moon. And the moon, because it's much smaller, has about a sixth of the gravity of the Earth. And that's why you would weigh less and you kind of float out there. And there's a picture of Neil Armstrong on the moon. Got there in 1969. All right, Mars, the red planet. The last of the terrestrial planets, the rocky planets. It's named after the Roman god of war because it is red. And the reason it's red, it has a lot of iron oxide on its surface. Iron oxide is a fancy way of saying rust. So if you've ever seen rust on Earth, that's a similar color to Mars. It's about half the size of the Earth, but it does have 2 moons on it. And because it's smaller, it has less gravity as well. Its atmosphere is mostly carbon dioxide, a little bit of nitrogen, and a little bit of argon. It does have a very small amount of oxygen and frozen water. And it has very big dust storms there. So go ahead and pause here while you finish up your inner planet notes. All right, we've passed the asteroid belt. Now we're to the outer gas giants. Jupiter is by far the biggest planet. It's named after the Roman god Jupiter, who was the ruler of Roman gods, and they named it that because this is the biggest planet. And it has, you can see it here in the picture, something called the Great Red Spot, which is basically a never-ending hurricane. And it looks kind of small, right? This little Great Red Spot is actually bigger than Earth itself. Jupiter rotates faster than any other planet, so a day on Jupiter is only 10 hours. It does have rings, but you can't really see them much. They're mostly made of dust that gets pulled together by gravity. All the outer planets have rings, but they're not very visible on Jupiter. They are there, but it's hard to see, especially from Earth. Very windy planet, and because it's so big, it has a lot of moons, 95 moons. Saturn, there's your ringed planet, the one everyone knows about. Saturn is the second biggest star in the solar system, and its rings are made up of ice and ice-covered particles, so very vibrant, big, noticeable rings. And even though it's not the biggest, it was able to gather the most satellites, 146 moons. This planet's 95 times heavier than Earth, so the gravity is much stronger there. But it takes about 29 and a half years to orbit or revolve around the sun one time. So 1 year on Earth, one Earth year would be 29 and a half Saturn years. Uranus is a planet that's kind of on its side. And we know this because of the way the rings are arranged around this planet. It's kind of tilted. Scientists think it might even got hit by an object early in its formation that tilted it on its axis. But it is the only planet which rotates on its axis from east to west. It has 28 moons, and it's very cold. It receives about 370 times less sunlight from the Earth because it's so far away, and that's why it is so cold. The last of the planets, Neptune, most distant planet from the sun, and it's named after the Roman god of the sea because of its blue appearance, and is the windiest planet of all. You cannot see it you'll never see this just looking up at the sky. It has 16 moons on it, and 1 year, one revolution around the sun is 164, almost 165 years of ours. And Neptune actually was predicted to exist due to math, like they could tell its gravity and did some math computations before they actually saw it with a telescope, which is kind of cool. So copy this down, and this is your last set of notes. After this one, you are done.